Good morning, good afternoon, good evening, depending on where you have joined us from. This is P. Nageshwar Rao. I'm a DevOps consultant and architect. I do a lot of online trainings, a lot of corporate trainings. I help a lot of companies to bring their processes on DevOps culture. I also help different companies resources to bring on DevOps. Today, I'm going to walk you through what is DevOps, what are the different tools that are involved in DevOps, and what would be the roles and responsibilities of any DevOps engineer in real time. And we'll see why DevOps is very popular and different, the demands, career demands of about DevOps. And I'll also unmute you all at the end of the session, and then I'll take your questions if you have anything related to career and things like that. This demo come career guidance session is arranged by Wiculty.com. Wiculty.com is a extensive, exclusive DevOps and then cloud related learning hub. Okay, let's get into that. So as part of the DevOps, we have these tools. First and foremost, we have something called Git. Git is called as a version control system, or you call it as source code management tool. Then we have Maven. We have different build tools like Ant, Maven, Gradle, and things like that. Maven is a build tool. You'll understand what is build and what is a source code management tool and things like that. Then we have Jenkins. Jenkins is called as a CI/CD tool, continuous integration, continuous delivery, or deployment. Then we have Docker. Docker is a containerization tool. And we have Kubernetes. Kubernetes is called as orchestration tool for managing containers, or think it as container management tool, right? And we have something called Ansible. Ansible comes under configuration management tool. We have Terraform in the same area. Terraform, it's also a configuration management tool, as well as you can call it as a cloud provisioning tool. And we have Puppet also in this area, Puppet. And as a DevOps engineer, if you have knowledge in some, say, cloud platform like Azure, GCP, AWS, it's kind of added advantage for us. So cloud platform. And main thing, if you are following the DevOps trends these days, there is a buzzword called DevSecOps. What's it? DevSecOps. DevSecOps is nothing but DevOps with a security related tools automation in place, right? I'll also walk you through what is DevSecOps and things like that. These are the major tools you have. You have a few other tools like Tomcat, and then you have testing frameworks like JUnit, right? You also have Selenium. We are not as a DevOps engineer, you don't need to master JUnit and then Selenium and things like that, but we should know how to integrate these tools as part of end-to-end build and deployment ecosystem. And there are different tools, for example, Linux, right? And if you know any scripting language like shell scripting, it is kind of again great added advantage. Any one scripting for that matter, like shell, Perl, Python, or it can be anything. So these tools are very small, you don't need to worry about that. But otherwise, these are the major DevOps tools we have. Okay. So here at Wiculty, we cover all these tools, and then we have a few other, the small tools, which are not listed here. So we cover all those things, and primarily I handle DevOps trainings in Wiculty.com. Okay, so what I'll do now to make you better understand what is DevOps, Dev plus Ops, development plus operations. Here, when you say Dev, doesn't matter that it doesn't mean that we have to do the development. we automate development and then operations related processes. That is something called build and deployment process. You'll understand in a minute, like when I explain all these things. So to make you better understand about these tools, let me take a project as an example, a project called Flipkart, for example. Let's see how Flipkart leverages these DevOps tools to speed up their development, QA, and then provide a stable applications to the end users. In other words, let's see how these tools help Flipkart to achieve that time to market and then speed up build, deployment, QA, and then operations processes. I think that's a best way to understand these tools. Let me get into that project. So it's a Flipkart, right? Flipkart. Assume that Flipkart has 100 developers. How many developers you have? 100 developers. What do these developers do? Developers write the code for application. It can be C, C++, Java, .NET, or anything. Assume that Flipkart is developed in Java. So a developer in Flipkart writes code something like this. For example, they write login.java. Java code always ends with .java extension. So this is login.java. For example, to create a login button, a developer writes code something like this. For example, button bt is equal to new button bt dot create, something like this. Don't worry about the syntax. It's just a pseudo code. Okay, as a DevOps engineer, we don't need to write a single line of Java code. That's not our responsibility. It's the responsibility of developers. So developers write the code to generate a login button. You go to any application, you have login, search, and then different widgets, right? In this case, this developer writes a code to create this login button. So you execute this particular code and you should get login button as an output. That's the expectation here. But unfortunately, machines cannot understand what you have written here. You cannot directly execute this .java file. No, because it is just plain text. We call it the source code. Source code means whatever we directly write. We all know computers understand only what? Machine language, right? Or you call it as binary or whatever, correct? So we have to write the code in machine understandable code, or call it as binary, or simply executable. Is it possible for us to write the code in machine understandable language like this? Binary? No, very difficult, right? Why? See, for example, you have to write something like this. C is equal to 10 plus 12. You have to convert this to equivalent binary, right? 1010 plus 1100. How do you convert a number to the binary? 8421. 8 plus 2, 10, 00. 8 plus 4, 12, 00. See how difficult it is to convert? Again, you have to convert this plus to equivalent ASCII, and then from there again to the binary, the semicolon you have to convert, C, and a lot of things. Very difficult for us to write the code in machine understandable language. So we write the code in our own understandable language, that is plain text. Machines don't understand, and whatever machines understand, we cannot write the code. So the question comes, how do you bridge this gap? If you remember, at least in academics, when you wrote C, C++, Java, .NET, once you write the exam, once you wrote, say, a code, you would have compiled it, correct? Why do we compile the program? What happens when we compile the program? When we compile the program, compiler checks the language syntax, semantics, grammar rules, and everything. And if everything is working fine, then it converts this particular plain text, that is source code, into the machine understandable code for us. In case of Java, you compile login.java, you get login.class file. So the problem is solved now, right? You write the program in your own understandable language, and then you generate machine understandable code by compiling it. And now you just run this particular code on top of any operating system, and then you get your output. Can you directly execute source code and then get the output? No. This is how the code execution happens. This is how you launch applications, right? Here it is only login button. Again, you have search and then you have different logic and stuff like that, correct? Okay. This is happening with only one .java file. But if you go to real time, like Flipkart project, you may be having thousands of .java files. Assume that, if you go to Flipkart, you have 10,000 or 20,000 .java files. Until and unless you compile all these .java files, can you launch the application? No, right? So how do you compile it? The question comes, right? Manually? No. It takes more time for us to compile, all these thousands of .java files manually. That's where in software we think about a tool, right? In Java world, if you want to compile thousands of .java files, we have a tool called Maven. Maven is called as what? A build tool. It builds binaries from the source code. We call it as what? Build tool. So when you have to compile thousands of .java files, you just pass this 10,000 .java files to Maven. Maven can compile all these Java files and then generate equivalent 10-20,000 .class files for us, machine understandable code, and then you execute it, right? So we call it as a build tool. We use Maven to automate the code compilation process. That's called as a build tool. Now you understand how developers write the code and what we have to do to launch application from that particular code. Developers' job is developing or writing the application code. DevOps engineers' job is what? Automating that code compilation process and then generate machine understandable code and deploy that code into server so that users and then QA teams can access that as an application. That's what we do, right? Now we understand what is Maven. Let me integrate Maven with Git and then see how these two tools work together, right? So let's go back to our project. It's a Flipkart. Flipkart has 100 developers, right? These developers write the code in their local laptops or desktops, and then they all connect to a server called Git. Git is the place where we store complete applications source code, correct? That means all these developers connect to this particular Git server and then they place their application code here. For example, a new developer joins in Flipkart. What does this guy do? This guy connects to Git, clones the code, adds some new file, modifies the code, and things like that for bug fixes and then new features. Again, they submit the code back to Git. Again, another developer takes the code, modifies, and then submits the code back to Git. That's how different users, teams collaborate with each other. So, end of the day, we have the application code in Git kind of source code management tool. We call it as what? SCM tool, source code management tool, because this tool helps us to manage the source code in an efficient way. Multiple users can collaborate with each other without overriding each other's code, right? And then you can see the complete history of the code, who has done what and then what has been modified and things like that, right? So Git is the place where we store complete applications source code. Okay, so here we have the source code. Source code can be anything, right? It can be .java. There may be some HTML files. There may be some CSS files. There may be some JavaScript. There may be some XML files, maybe some TXT, images, and things like that. There can be anything. We don't worry about this. It's responsibility of developers. Actually speaking, it's not only the developers, right? QA people also write the code. DevOps engineers also write some automation scripts. And then maybe operations teams also write the code. Whoever is working on the project, all these teams write the code and then they place the code in Git. So in Git, you have the complete applications code, right? Every day, these developers develop the code. Every day, DevOps engineers clone the code, right, from Git. Every day they develop the code, they place the code in Git. Every day, DevOps engineers clone the code from this particular Git. And guess what we do here? Once we clone the code, we go and then build that particular code, and then we generate class files. So once the code is committed to Git, DevOps engineer clones the code, and then we build it. Say we compile it. Okay, we've just discussed when we clone the code, you get .java file, you get HTML, CSS, images, blah blah. So you have everything. Assume that you have 10,000 files here. When you clone, you get 10,000 files, everything. This guy is DevOps and this is DevOps engineer's mission. Using Maven, right, we compile the code. We have just discussed, right? Until unless you compile all these thousands of .java files, you cannot launch the application, right? So we have to compile it. How do you compile? Manually? No, right? We use a tool called Maven. You just execute a command, for example, mv install. Maven compiles thousands of .java files and then creates equivalent machine understandable code, that is class file for us. To execute the application, it's not just Java code we need. We need to have a lot of other supporting files. For example, we may need some HTML files. We may need some CSS files. We may need some images and then JavaScript files and things like that, right? So apart from generating the equivalent class files, we also separate all other resources which are required for application to run. We don't know what files are required. In Maven, developers write something called pom.xml files. In pom.xml, they configure what resources are required for application. When we execute that Maven command, Maven compiles and then separates all other resources which are required here. So here you have some HTML files, some CSS, and then JavaScript and stuff like that. We call this process as build process. What is that? Build. We build applications. We build binaries from the source code. Can you launch application from this source code? No. Somebody has to transform this particular source code and then generate machine understandable code. We do that. And do we do all these things manually? No. We automate this process. It is like this. You just execute a command or you just click a button, right? The moment you click a button and then run a command, the command should automatically take the code, run this, invoke this Maven command, generate the class fields and then deploy it to the server and stuff like that. So we automate that process. You understand that? Once we have everything in this particular folder, for example, we compress this and then we create something called var file. For example, flipkart.var, web archive. It's like a zip file, right? So we create that. So you have a file called var, and then in that var you have application executable code. If you have this var file, you can launch Flipkart application, right? Once we create that particular var file, then we go and then deploy that var file into a server called Tomcat. This is Tomcat server. We have to deploy it. So you deploy this particular var file in Tomcat. That means you have to take a server, you have to install Tomcat in that, then copy this var file into this machine. You call that as release or deployment. Build and release, build and deployment. Deployment means copying the var file into Tomcat is called as a deployment. Okay. Now This mission Tomcat server name is flipkart.com. Flipkart.com. Once you build and then deploy the code, then the real users can access the application now. How do end users access the application? Users say, for example, they open the browser and then they say www.flipkart.com, right? The moment users type flipkart.com, which is this mission's name, no matter where the user is, where the server is, this browser connects to this particular mission using network. And here we have the var file, which is mission executable code. And there is a guy running here, Tomcat server. This server executes the code and then it sends HTML response back to the browser. And here you see login button, right? Search box and stuff like that. You see the application. That's how this developer's code becomes as an application. That's how end users access the application. So in order to make this application's code, right, development team's code as an application, somebody has to build it and then deploy it into the server and then start the server. We call it as what? Build and deployment. In fact, as a DevOps engineer, we strive to do this. The moment developer commits something, for example, developer commits something at 2 a.m. without our presence, right? We try to take the code automatically, build it, deploy it, and then send an email notification to the user saying, okay, your code is built and then deployed, and then you can access from the browser and then you can test it. We target to that level of automation, right? We'll do that in Jenkins. Okay, I'll explain that later. Right. You know what is Git now? You know what is Maven? Git is a place where we store the code. Using Maven, we automate the compilation process. Just a small demonstration, right? There are a lot of other things involved. I'm just explaining the things at a high level, just for your understanding. Now, let's see where Jenkins come into picture, right? Okay. Before that, actually speaking, we don't directly push this particular var file to flipkart.com. We have to test that code, right? In real time, actually speaking, we'll be having some QA environments. This is production environment where the live users are connected. You know what we do every day? We have some test environments. For example, here you have 2 environments. Means every day they write the code for bug fixes, feature development. We take it and then we create the var file. Then we first deploy that particular var file into these test missions. You call this as QA. You call this as SIT, System Integration Testing Environment. So here you have the var file and then you copy it. You have 2 QA teams. Once we deploy the code, we send email notifications. All the things we can integrate, okay, automatically. Then your manual tester, he comes and then connects to this. There is another testing team called System Integration Testing. Their responsibility is to test the complete code as a system, right, end to end. So this guy is a manual tester. They launch the application by connecting to this. Name of this mission is flipkart-qa.com. Name of this mission is, for example, flipkart-sit.com. If this guy types flipkart.qa.com, right, f.qa.com, for example, so he gets the code from here. And this guy types flipkart.sit.com, for example. And this guy gets the code from here. So these guys every day do the testing. Every day developers develop the code. Every day these QA engineers test the code. You may be having multiple environments, different environment for different users. An environment means what? A place where your application is configured. A place from where you are accessing the application from, right? Okay. So every day we'll be building and then deploying the code to these QA environments. If you see here, we are interacting with these development teams and then QA teams very frequently, right? In fact, we can say DevOps engineers are acting kind of interface between dev and then QA. Who is making this development code reach to the QA? It is DevOps engineer. Until unless you take it, build it, and then apply it, QA people don't have application for the daily testing, right? So in this process, we'll be working with development team and QA teams very closely. For example, say this. You are compiling the code. There is some compilation error here, correct? Who has to fix it? We are not developers. We don't know how to fix that compilation error. So what do? We report that compilation error to the developer. Developer fixes it. They place the fix here. Again, we take the code. Again, we compile it, and then we deploy it. So in that process, we closely work with the teams, development teams. Assume that the QA guy is accessing application flipkart.qa.com. This environment is down. Tomcat server is down, or there is some space issue, there is some network issue, or things like that. This guy comes to you. Hello, DevOps. This environment is down. I'm unable to launch the application. I have to do some testing. Can you please bring this environment up and running for me? It is impacting my daily testing. I'm unable to reach my QA deadlines. Can you bring it up? So what do? We go to this mission. We check whether the right WAR file is deployed or not. We check if there is any network issue, a space issue, and stuff like that, and then we bring it up. If it is our issue, we solve it, resolve it. If it is not, if it is other team's issue, we engage other teams and then we get the issue fixed. See how closely you are interacting with development and then QA teams. That's what dev means in DevOps. Dev plus ops. Here dev means it's actually development and then QA teams. You automate development and then QA teams processes. Dev doesn't mean that we have to do the development. There is some misconception, right? People think that, yes, I have to do the development also. No, you're not replacement for the developers. You're not replacement for the QA. You're not replacement for the operations team also. It's just that we connect the dots between all these teams, right? This guy is development team, QA team, right? We come in the middle, we do the build and deployment so that QA people can get this development team's code. Once you deploy the code into Tomcat server, then comes operations teams, right? Let's discuss that. So you understand the term called dev in DevOps, okay? So we call these QA environments as lower environments, and flipkart.com live environment, or you call it as higher environment. Okay, let's see what is this Jenkins. Okay, why Jenkins is required. Jenkins is again a very important tool in DevOps. Using Jenkins, we can achieve that continuous integration. That means the continuous build, continuous deployment, continuous testing. Where Jenkins come into picture? This is where Jenkins come into picture. This is Jenkins server. So we take a mission, right? We install Jenkins in this mission and we launch Jenkins in the browser. Jenkins is a browser-based tool, right? Once you install Jenkins, you launch Jenkins from the browsers. Okay, so you have Jenkins installed here. Now you launch Jenkins in the browser and you create something called project. It's very simple. At a very high level, you think in this way. In Jenkins, we integrate clone, build, deployment steps so that this build and deployment process can be executed seamlessly. That's the target of Jenkins. You'll understand. So I have Jenkins installed in this mission. Then I launch Jenkins in my browser, and then I create something called project, or you call it as build pipeline, or you call it as whatever, say job pipeline. Here we give the git URL. We give this maven command, which will compile and then create the WAR file for us. We give all this deployment related commands, which will copy the WAR file to the Tomcat. Then probably we give email notifications settings, like who need to be notified when there is error, or when the build and deployment is successful, or things like that, right? Okay, you integrate everything here, and then we configure Jenkins in such a way that we configure this project in such a way that it connects to Git for every 5 minutes or 10 minutes. You can decide that, a poll option. We call this a polling. Polling means continuously hitting something, right? So we configure this project or Jenkins in such a way that it talks to Git for every 5 minutes. And then it asks Git, hello Git, do you have any new code? It says, I don't have any new code. It will come back. Again, 5 minutes, it will go and then check. Do you have any new code? Assume that it's a 2 a.m., right? So when developer is working late night, for example, once he commits the code, he wants to test it, right? So somebody has to take the code, build it, and then deploy it into the QA environment. Then only this guy can test it, right? Does it mean that you have to be awake? No. You have just configured your tool. You have automated. You have the reliable automation in place, which will automatically take the code, build it, and then deploy it, even though you're not present. So what Jenkins does, the moment it detects a new code, it will take the code and then it will build the code, right? Because here we have given the Git URL, it polls to this particular Git repository for every 5 minutes. The moment it detects the code, it will take it, it will execute this particular maven command, right, which will create the var field. Then it will execute the deployment commands, which will deploy the code, and then it starts the server, and it sends email notification also saying, okay, build and deployment is done. It can be a prod, it can be QA, or it can be any other environment. See what Jenkins is doing. Without Jenkins also, we can perform the builds and deployments. If you have Jenkins, you can continuously monitor for the new changes, build it, and then deploy it. Correct? We call this process as CI, continuous integration or continuous delivery or deployment. There is a thin line difference between CI CD. I'll clear that later. Okay, fine. So what is continuous integration? Continuous integration is a process which will detect the change coming into source code management tool, take the code, build the code, and deploy the code to given environment seamlessly without any manual intervention. That is called as continuous integration, right? It executes the build and deployment process continuously for each and every change that comes in Git without any manual supervision or manual intervention. That is a CI. People sometimes say CI/CD. What is that? It's very simple. If you are continuously taking the code and then deploying it to the QA environment, you call it a CI. This is continuous integration. How continuously you integrate this developer's code with existing code so that QA people can test it. CI, continuous integration. You can also do this, right? You deploy the code to a QA environment, then you trigger some test cases. Everything is automated here. So you trigger some test cases, and then you can set up some threshold basically. If the test cases are successful, say 90%, 90% test cases are successful, I will deploy this particular code to the prod. Again, it can go through multiple levels. And just a link, right? So if 100% test cases are successful, move it to prod. See, even though a developer commits something at 2 a.m., your automation is detecting it, building it, and then deploying it to the QA, running some automated test cases, and once the automated test cases are successful, it is automatically pushing it to the prod. See how seamless it is. If you go to Amazon, Google kind of technology-centric companies, they try to push the new code to the prod within 2-3 hours or few minutes. See how fast their development is, how fast their QA is, and how fast they are able to release their new features and push the bug fixes to the real users. Correct? We call this as continuous deployment, CD. Deploying to the QA is called as CA, deploying to the prod is called as continuous deployment. Again, there is a subtle difference between continuous deployment, continuous delivery, right? Sometimes, it depends on the application. Once the code is deployed to the QA, we run some test cases. and we manually verify whether everything is good or not, and then only we push it to the prod, because we don't want to make any mistakes there. It's a very sensitive application because it's a production, right? So there is a small manual intervention here. If you are manually verifying it and then pushing it to the prod, you call it what? Continuous delivery. So people interchangeably use this terminology, right? It depends on the project, company, how you are treating this terminology. Clearly, right, at a very high level, if you are deploying the code to the QA, you call it as CI. If you are deploying to the pod, you call it as CD. Again, if it is an automatic deployment to the pod, continuous deployment. If there is any manual intervention, it is continuous delivery. That's about it. CI/CD helps you a lot to move the code to the pod, and then it gives the fast feedback to the users. Basically, the moment assume that 500,000 users are working in our environment. The moment it gets a code, it will build it. If there is a compilation error, for example, you don't need to manually look at it. It will automatically send an email to the developer who broke the bed, developer who introduced that compilation error. Again, when this guy commits the fix, again it will take it automatically, again build it and then deploy it. So this build and deployment executes continuously, no matter how many users are working. Continuous integration or continuous deployment. Correct? If you see, using these three tools, we are automating, as I said, development and the key teams process, and then we are closely interacting with these people. These tools come under dev. Then comes what? Ops. What is that? Now you have developed the code, built it, and then deployed it. And real users are accessing your application, right? Once your real users start accessing the application, then you have to concentrate on serving your application in a stable manner. It means it's a flipkart.com, right? Even 10,000 users hit my application should be running with the same speed, right? That's what we think after deploying the code to the production. Here, once you deploy the code, a lot of teams work to make this application stable. For example, application support team, production support team, your say operations teams, your network engineers, your system administrators, a lot of teams work on this particular live environment to make sure things are running stable. That's called about operations, maintenance, right? Once you deploy the code, then you go into maintenance mode. That's where all these tools come into picture. So using these tools, you can make sure that your operations part is automated, and then your application runs in a stable way no matter how many users hit. Let's talk about all those operational challenges and then how these tools help to solve all those issues. Let me explain. Let me start with configuration management tools. How these tools help, right? Flipkart project to automate infrastructure configurations. Means what? You'll get it. Okay, let me start with this story, right? Flipkart, it's a e-commerce platform. Those who don't know what is Flipkart, it's like Walmart.com, Amazon.com, right? Assume that Flipkart plans Big Billion Day or Amazon Great India Sales during Thanksgiving Day, Black Friday. You see huge discounts running in e-commerce platforms. There'll be huge traffic, right? Thousands of users, thousands of orders you get in a minute or a second. So assume that Flipkart is planning a Big Billion Day where there is huge discount running. Before that, I just want you to understand one thing. Do you think there will be only one server in the production, Flipkart.com? No, right? If you have only one mission, assume that 100 users can you can serve application, right, to 100 users. What if you get 1,000 users? What if you get 1 million, users? One machine cannot serve the application for 1 million users. So in real time, we'll be having multiple servers in real time. That means if you go to Flipkart, you may see 100 servers, 100 machines. 100 machines are processing your Flipkart traffic basically. So 100 machines are connected to something called load balancer, right? How it works? Whenever, say 1,000 users type flipkart.com, it goes to this flipkart.com load balancer. That means it's a mission, separate mission server. Here the load balancing software is installed. Responsibility of this software is to distribute different users requests to different machines so that all users requests can be processed in parallel and you can serve, your customer requirements. So 100 servers are attached to this load balancer. The moment it comes to load balancer, it distributes the load and then your, users requests are processed in parallel, then you serve the application. If you get, say, more users again, for example, you have to go and then add more and more machines. So assume that Flipkart has 100 servers. 100 servers are processing a real users traffic, right? Okay. So Flipkart plans for the big billion day. For a simple math, think that Flipkart receives 100 orders per minute in regular business hours. Okay. It's a big billion day, right? They expect 500 orders per minute, OPM, orders per minute. They expect how many orders? 500 orders in a minute. See, in Wiculty, when we learn DevOps, we practically automate all these things, whatever I'm explaining, whatever I'm going to explain. It's not kind of a theory or slide-based training. We have our own project called Gamut Card, kind of a capstone project. It is a real-time kind of project. You take that project source code, you'll be literally creating, this repository. You call it as a repository. You'll be setting up the Git server. You'll be building it, deploying it, setting up the load balancer with multiple servers and then multiple queue environments. A lot of stuff. It's a pure practical way. Okay. 100 orders per minute. It's a big billion day, right? They expect 500 orders per minute. So, you know what Flipkart Teams does? 10 to 15 days before the release, Flipkart goes and then adds, 400 more servers. To process 100 orders, they need 100 machines. To process 500 orders, they need 500 machines. So 10-15 days before the release, they take a mission, they install Tomcat, Java, Python, database, they create the user, set up the password, they create a file, give some permission, you create a mount point, you create a Linux group, a lot of configurations you have to do. Maybe 100 configurations are required in each mission. So you have to configure all those things in 400 missions. So they're ready with the infrastructure. They have added more missions to the load balancer. Okay. Big billion days started. You started receiving 100 orders per minute. You started receiving 500 orders per minute. Is there any guarantee that you don't receive, 1,000 orders per minute? Possible, right? You started receiving 1,000 orders per minute. Okay. Do you have infrastructure to process 1,000 orders in a minute? No. You have only 500 missions. So what do? To process 1,000 orders per minute, you have to go and then add 500 more servers, for example. We call it as scaling up the infrastructure, adding more and more computing power, scaling up infrastructure. So you have to scale up the infrastructure now. Do you have time to go and then add 500 missions? No, right? If you remember, it took 10, 15 days for you to add 400 more servers. You don't have time, basically. That's the problem you face. As a result, what happens? You give such a bad user experience, right? Your application becomes slow or it gets crashed. So the question comes, How do you minimize this risk? How do you scale up the infrastructure based on users' demand, based on your, say, traffic? That's the question comes. That's where your cloud and then configuration management tools come into picture. Let's see how this Ansible helps us to bring hundreds of missions without much work, dynamically based on application load. Ansible, right? If you have Ansible, you know what we do in Ansible? Here, earlier you have configured this 400 missions manually. Assume that. In Ansible, you know what we do? Whatever configurations are required in this mission, we define all those things in something called YAML file. Okay. I'll say I want JDK version 1.8. I want Tomcat to be present there. I want Tomcat to be running. I want to have this Python version. Whatever configurations are required for you, you define everything in this Ansible configuration file. We call this as a playbook, right? And then when you have to add more and more missions, you just bring these 500 servers from some cloud, okay? And then you go and then apply this Ansible script. You execute Ansible script on 500 missions. Ansible can configure all these 500 missions for you within a few minutes. See how quickly you are able to configure the infrastructure related things. If it is manual, if it is a human who is configuring, it's error prone. There is no guarantee that you configure 100 steps in 400 missions accurately. There is no guarantee. It's a time taking process. If it is a tool, it can get something done accurately and very fast, right? So here Ansible is helping you to automate infrastructure configurations. You call this as infrastructure as a code, IAC. You don't manage your infrastructure as a human. It is the code which is managing your infrastructure. Infrastructure as a code. It has a broad meaning, but in simple words, right? Infrastructure as a code. Okay. See the role of configuration management tool. It can be Ansible, it can be Puppet, it can be Chef and things like that. Here in Wiculty course, you learn Ansible, you learn Puppet, you learn Terraform also, because it's kind of very important area. Okay. So here Ansible is helping you to scale up the infrastructure configurations. Okay. And before you apply Ansible, you should have infrastructure, right? You should have 500 missions. So what do? Before Big Billion Day, you buy 500 more missions just for one day, Big Billion Day. What if you need 1,000 more missions? How do you know how many missions you want, right? Is it possible for us to buy 2,000, 3,000 missions beforehand and then keep it ready? We know the cost involved there, correct? We cannot do that. So the question comes, right? How do you bring more and more missions? That's where we bring the cloud concept into picture. Cloud says when you need more and more infrastructure, just look up the cloud and then say, hello cloud, I want 500 missions. This cloud will give you 500 missions. That means you can create 500 missions in the cloud. And who is this guy? This guy is Amazon, Google, right? Microsoft, Azure. So they have huge data centers. They have huge infrastructure. They say when you need missions, infrastructure, don't buy on your own. Instead, you just tell us and then we'll give you 500 missions or 1,000 missions or whatever you want, right? We call this as infrastructure as a code. What is that? Infrastructure as a code, IaaS. Don't buy the infrastructure on your own. You use it as a service. You pay for what you use. Pay as you go. You want 500 missions for 24 hours? Just pay for 24 hours. That's all, right? So we provision the missions from some cloud platform. We apply Ansible, and then we add more and more missions to the load balancer, and then we serve the traffic, right? As a DevOps engineer, if you know the basic or intermediate level of cloud, it's kind of an added advantage. We have the cloud experts basically. We have say there's something called AWS for system administrators, AWS for the developers. There's something called Associate Solution Architect certification course, Professional Solution Architect. So these people will help us to automate the cloud related things. Understand what is cloud, where cloud IaaS come into picture, and then Ansible, right? How we integrate both to scale up the infrastructure, right? We know what is Ansible, right? And then we know what is Terraform or Puppet. Terraform is just like the Ansible only, okay? And think Terraform in this way. Say you need 500 missions, right? When you want to provision 500 missions, create 500 missions, so you cannot create one by one, right? It takes more time. So you using up Terraform, you know what we can do? You can say Terraform, hey Terraform, bring me 500 missions, and I want a mission with this, say, computing, with this RAM and then CPU hard disk, and then once you create a mission, you put that particular mission in this particular network, and then with this configuration stuff from this particular the region and things like that. So you write all those configurations in Terraform, just execute it, and it gives you 500 missions with required configurations. Correct? Okay. One point here, I said we cannot buy the hardware, right? 500 missions on our own. Why? Because we have to maintain it, right? We have to maintain these servers. That means if you have to manage, you buy first thing, it's not one-time investment, right? Again, you don't need the 500 missions next day. You have to buy, you have to pay that real estate cost, you have to pay rent, and then you have to buy some racks to place this 500 missions, cables, AC you have to purchase, power bill. You also need some manpower to manage those servers. See how much cost is involved. If you see down the line after a year, your maintenance cost would be double than purchase cost. So it's not a good idea to buy the infrastructure. That's where people think about the cloud, right? So for normal small projects or small companies, they cannot afford to have set up their own cloud like this. Very difficult. There are a lot of other reasons why we go for the cloud. Okay. Ansible Puppet helps you to see your infrastructure as a code, manage your infrastructure as a code, not as a human being manually. Terraform, you can provision thousands of missions from cloud with required configurations, and cloud platforms help you to cloud platforms enable you to provision the missions, right, at any point of time. So any number of missions based on your application demand. Okay. Now, if you see how this Ansible cloud, right, configuration management tool, and then cloud helping your Flipkart application, right, to run with the same speed, no matter how many users are hitting your application operations, right? And you can also configure the same, the tools. Whenever there is no load, you can again destroy this missions, and then you fall back to 100 missions. You can also do that. Scale up, scale down. You can also automate that basically. We call it the auto scale, right? Scale up, scale down automatically, auto scale. Okay. Another interesting tool, Docker, which is very important, right? When it comes to setting up the infrastructure. Let me explain what is this Docker. What is containerization? First of all. Okay. Docker is a containerization tool. Okay. So let me start with a very simple example to make you understand Docker in a better way. This is you have a mission basically. This is this is your computer. Here you have say assume 8 GB RAM. You have CPU, 8 virtual CPUs, octa-core processor, and then you have some hard disk drive. Okay? So you have 500 GB hard disk. Think in that way. This is your friend. Your friend also has a mission, and this guy is working on some project basically. He wants to execute that project code on a distributed environment. He wants to set up a database in one mission, and then front end in one machine, and then the back end services in another machine, and things like that for different reasons. So this guy needs 2 more machines. So this guy again has to buy RAM, CPU, and then things like that, correct? Before purchasing, this guy comes to you, says, can I use your machine? I want to run database and then different things on different machines. So I don't want to buy the machines. Can I use your machine? You say, this is my computer. I also need one. You have to go and buy your own. This guy says, okay. Can I ask you a few questions? Go ahead. How much RAM you have? 8 GB. How much CPU you have? Octa-core processor it is. How much hard disk space you have? 500 GB. Simple question. Are you using 8 GB octa-core processor and then 500 GB? You say no. Hardly my applications use 2 GB and then say I'm using 100 GB hard disk space. So this guy says you have invested a lot in purchasing the hardware and you are not utilizing to its max capacity. Can I share this hardware? Can you share this remaining hardware, unused hardware? Can I take the same unused RAM, CPU, hard disk, and then install operating system so that a machine is created and then I'll run my own application here? Can you share that remaining computing power? You say this is a physical machine. What's it? It's a physical machine. Once you attach hardware, RAM, hard disk, it is only for this. No matter whether you use it or not, you have to waste it, right? So you have the physical machine, you have your laptop. No matter whether you use 1 TB or not, right? You have to dedicate to that machine only. This laptop has 1 TB. Am I using 1 TB today? No. If I need another computer for something, what do? I have to again go and then purchase the hardware and then assemble a new machine, correct? That is the limitation we have in physical machine. So you say, it's not possible. You have to go and buy your own machine. And this guy, even though this guy buys, there is no guarantee that, he can use it. That's where we think about what? Virtualization. So what you do? You install operating system on top of, this particular hardware, OS, and then you install some virtualization software here. Virtualization softwares. Using this virtualization tools or techniques software, you can create multiple machines on top of the same hardware that you have in host. You call it as host. This is host. And this is called as a VM, right? Virtual machine. If you are creating a mission using virtualization technology, you call it as a VM, virtual machine. VM1, VM2, VMN. You can create n number of missions. Okay. What this virtualization technology is doing? This virtualization technology virtualizes the hardware for multiple missions. Even though you don't have, say, for example, RAM, CPU, hard disk for these missions, it distributes the same RAM, CPU for all these missions. That's a technology here, virtualization technology. Virtualization means what? Which is not physically present. You don't have the hardware, but you still are able to get it. And since you have the virtualization technology, you can create n number of machines here. Then you can install operating system on top of this particular hardware, and then you can run your applications. Application 1, application 2, application 3, and things like that. So if you have this technology, if you had this technology, you could have created 2 more machines and then give IP address to this particular friend. So this guy could have installed operating system and run his own applications here. See how you are utilizing your hardware to its max capacity. Virtualization technology is great even today, but these days infrastructure is moving from virtualization to something called Dockerization or containerization. Why? Let's discuss about Docker now. Why Docker is very important for us. What I do now, this is okay. So let's take the same machine. Okay, here you have RAM, CPU, and then hard disk type. I take I install some operating system. Then I go and then install Docker in this case. This is OS, and then here it is Docker. Using Docker also, I can create multiple missions. If you are creating the missions using Docker, you call it as container. Container 1, container 2, container n, the number of containers you can create. So you can, when you are able to create multiple missions on top of the same piece of hardware using virtualization technology, why you are going to Docker again? Because Docker is also doing the same thing, right? What is the difference between virtualization and then containerization? Let's explore that. If you have ever created, right, the operating system, sorry, if you have ever created a VM, you know this. To create a VM, you have to install operating system in each and every machine. That means each and every virtual machine has its own copy of operating system. Virtualization technology gives you only the hardware. On top of the hardware, you have to install a separate copy of the OS, then only you can run your application, right? Since each and every VM has its own copy of the operating system, there are some disadvantages. Since there is an operating system, it takes more time for you to create this machine, right? It takes more time to create a new machine. Okay, think those big, so how much time it will take, right? Close to 5 to 10 minutes to create one machine. Think those big billion days kind of days where you have to go and then scale up the infrastructure within few minutes, and it takes 5 to 10 minutes for you to create a VM, right? You cannot do that. It takes more time because you have to install it, right? It's not just creation. It takes more time for you to start the mission because you switch on the power button. You have to wait for the operating system boot process, right? You have to wait for the operating system to come up, close to 3 minutes. It takes more time for you to stop the mission. See that disadvantages? If it is Docker, right, it takes very less time for you to create a mission start stop. How? To create a container, you don't need to supply a separate operating system. In other words, you can say containers don't have a separate copy of operating system. You know what Docker does? Docker virtualizes the hardware, like virtualization technology. You get the hardware. It gives the same hardware to all these machines. You can think in this as well as Docker virtualizes the operating system also. That means you don't have a dedicated copy of the operating system in each and every container. You don't need to install the OS. But without operating system, how do I run my own applications? Correct? Application 1, application 2, application 3. That's where the Docker beauty comes into picture. So for user, it gives a feel that you have a dedicated operating system. You feel that you have operating system, but actually speaking, it runs all these applications under the same operating system kernel, right? So you can call it as your operating system is virtualized, right? For the user, it gives a feel that you have operating system, like whatever luxuries you get by having a full-blown copy of the operating system, you get all the luxuries. What are those luxuries? If there's an operating system, I'm running my operating system on top, I'm running my application on top of operating system means what, right? I expect a separate IP address so that I can allow other machines to connect to my application. So when you create a container, your container gets a dedicated IP address. Your container gets dedicated, networking capabilities. That means you can decide who can connect, who cannot connect to this application or mission. You get dedicated networking capabilities. You get a separate process tree. If you are running 10 applications here, you cannot see these 10 applications here. It's an isolated user space. Right? You get a separate process tree. You get separate storage capabilities, and then everything is separate. So when you have your own IP address, when you have your own networking capabilities, and then a process tree, and things like that. So it's like a separate mission for you. It gives you a feel that your application is running in a dedicated mission. But actually speaking, there is no operating system. All these applications are running under the same OS, right? With that OS kind of feel. You can think in one way. I mean, in one way you can think that Docker virtualizes the hardware as well as operating system also. Docker uses something called C group and then namespace kernel features to virtualize, to give this operating system kind of environment for this particular container. Okay, you think this way: all these containers run under same operating system, or you can think that all this operating system is virtualized. All these containers run as kind of a processes under the same operating system, right? The problem is solved now. You're able to run application as if there is a dedicated operating system. So that's the beauty of the Docker. It leverages those C group namespace kernel features. It's like a programming technique, right? It gives you an environment that you can run application on an kind of a dedicated operating system. It just gives that all those say advantages to you. Okay. If it is a regular class, I spent almost 1.5 to 2 hours to just explain how Docker creates this container without you installing the operating system, how it emulates that process basically, how it gives you the operating system, right? Okay, there is no operating system. Since each and every container don't have the operating system, it takes less time for you to create a container. In fact, you can create a mission within less than 1 second. Within less than a second, your mission is ready, right? During this big billion days kind of days, if you want to create 100, say if you want to create 500 missions, you can create within less than few seconds because you don't have to install operating system. It takes less time to start the mission. You don't have to wait for the operating system to come up. There is no one, and then it takes less time to stop the mission. See how quick the container creation is, right? In fact, VMs are heavy. VMs are heavy in nature. Why we call it the heavy? And containers are lightweight. Why VM is heavy? You have the operating system. Okay, you buy a mobile 64 GB. Do you get 64 GB? No. 60 GB, 58 GB. Where is the remaining space? Occupied by your operating system. By having operating system in each and every VM, you're wasting a lot of computing power. Your operating system takes some hard disk space. Your operating system means it's a code, right? It takes RAM, it consumes your processing power also. So by having the OS, you are wasting a lot of hardware here. Whereas here, you don't have operating system, right? All these applications are running under the same operating system, correct? With that OS, a dedicated OS kind of luxury feel. So since operating system consumes a lot of hardware, since you are wasting a lot of hardware here, it takes more, you need more hardware to create more missions. Whereas containers takes less resources. For example, assume that you have this mission. You can create 5 VMs max. Think that way. If you can create 5 missions, right, 5 VMs on top of this hardware, on top of the same hardware here, you can create 50 containers. It is that difference, 50 containers. Why? You don't have, you're not wasting hardware by having the OS. Container is lightweight, whereas VM is heavy because you have a dedicated operating system. There is one more major advantage called image. Okay, in Docker, you can ship your application to the customer along with the code and the prerequisites. That's a huge advantage. It's very difficult for me to make you understand what that image is, right? So in these kind of sessions, but let me at a very high level, even if you don't understand this, just leave it. Okay, don't blame me. It's very simple. At a very high level, this is what you can do with Docker if you have. See, one simple thing. You have the var file, right? In VM, assume that it's a VM or physical world, physical machine world. What do? You create a var. Before you deploy the var file into this machine, here you should have right version of Tomcat. And to run Tomcat, you need to have the JDK. You need to have Python. You need to have that, these, and a lot of things. A lot of tools you have. So to execute your code, this is a code, right? To execute the code, you need to have some prerequisites. You need to have some, dependencies basically, different, softwares, and it's not just, one version, right? You need to have a particular version of, the software. When you have QA environment, when you have, production environment, when you have SIT, UAT environment, when you have, say, stays, performance environment, when you have multiple environments, it's a real challenge for you to make sure that are all environments have the same version of the dependencies prerequisites. If you have one version here and then different version here, things will not work. It works here, it doesn't work here. Works in my mission problem. It works in one mission, doesn't work in other mission. It's almost kind of a nightmare for you to ensure that all environments have the same code and then same version of the tools or prerequisites. So that's one challenge. The other challenge, before you deploy the war file, you have to install all these prerequisites here, then you deploy the code, right? Installing, managing it is one aspect of it. And the second thing is making sure that all environments have the same version of tools or dependencies. Very difficult. That's where Docker comes into picture. Docker images. If you have Docker images, what you can do? It's very simple. I generate the war file, right? I have the war file here. This is my code. To run this code, what I want JDK. I want Tomcat. And then I want to say Python, for example, some version of the Python and some operating system. So you bundle everything as an image. This is called the image. Think image as a zip file. Zip. You include multiple files in a zip file, right? Archive. It's kind of an archive. Think in that way for now. So once my build is done, I get the war file. Whatever is required for me to execute this particular war file, right? I bundle everything into one image. That's all. And I need to create, say, 10 missions for production. You know what I do? From this image, I create 10 missions. We create the container from this image. When you create a container from the image, you know what happens? Whatever you have included in this particular image, same thing comes in the container. If you have bundled JDK, Tomcat, and everything, same thing comes in all this container. So one thing, you are able to create one container within less than a second, and then your container has already the dependencies, prerequisites, plus the code also. See, here you have to install and then deploy in traditional deployment. But with Docker images, you get a mission within less than a second where you have everything out of box. See the beauty of Docker image. So during big billion days kind of days, if you want to create a mission, if you have a Docker image for your application, you can just create a container here within less than a second, which has everything. How quickly you can scale up your environment. Have you ever seen Google search going down, going slow? Gmail, Google file system? No matter how many millions of users hit Google search, they still serve the application at the same speed. For you, to get one search, one page with search result, 10 to 15 missions has to work. If you search something in the Google, right, you get the result, right, search result. To serve one page for one request for one user, under the hood, they run 10-15 missions. That much of processing. How many missions they want? Correct. And they have to add more and more missions based on the demand. So if you have the image, you can set up the infrastructure within very less time. You call this as application containerization. Containerizing your application. Application containerization means what? You are able to run your application in containers. You are able to run your applications in containers. You have containerized your applications. These days, right, most of the companies are trying to containerize their application, are trying to run their applications in containers because of all these advantages. Less cost, you can create stop missions very quickly, right? And then you can scale up, scale down the infrastructure, right, within a very less time. Understand the Power of Docker images. Not sure whether you got it or not about the image, but it's a huge topic. Hope you understood that. Let's move on. So we'll be, see, as I mentioned, when you take the course in Wiculty, right? We have our own project. For our project, we'll first build and then deploy the code in a VM, right? Then we go to Docker. We learn all Docker concepts like how you get the container, how you start it, stop it, how exactly the containerization happens and things like that. Then for our application, we create the images. Literally, we create the images. Then from the image, we create 10, 20 containers, and then we launch the application from the browser. So we'll be configuring all the things, right? This is about the Docker. Where Docker comes into picture? Here, your QA environment missions, your production environments can be physical mission. You can have the VMs, you can have Docker containers. If it's a container, you have seen the advantages, right? So infrastructure is moving from physical missions to the VM and then VM to containers, right? That's the trend. You are witnessing all the advantages of this users, right? I mean, all the advantages of these tools, how these tools helping, right? A Flipkart, correct? Okay. We know what is container. Then what is this Kubernetes at a very high level? See this. You develop your application in your favorite language, C, C++, Java. You store it in your favorite version control system. You clone it, you build it, you create the package. Then you create a Docker image for your application. And once you have the Docker image, what do? We go and then create an environment. This is the image, right? From this image, we create environment. Say I want 100 containers. So 100 containers in the pod. So from this image, we create 100 containers, and then 100 containers are running your applications. Correct? So Docker jobs end at creating the image. Once you have the image, who will create 100 containers and who will manage this 100 containers? Assume that you have 100 containers in your prod, okay? 100 containers in your production environment, right? Okay, this is the image. From this image, okay, you have containers. You have created 100 containers. Or if it is difficult for you, image, just think that for now, you have 100 containers, okay? Containers. Okay, at any point of time, I want to have 100 containers fixed for my Flipkart e-commerce platform. If I have 90, then application will become slow because I have expected, customers basically. So if 10 containers go down, due to some hardware failure or a disk space issue or anything, I should be able to bring 10 up within very less time, right? But if 20 goes down, I have to bring 20 up. Otherwise, my application will become slow. So the question comes, who will monitor all these 100 containers? And then who will bring the replacements? You have to have the monitoring system. Somebody has to go and then create 10 containers replacement again. Very difficult for you to do this continuously. If you want to even automate this, very difficult for us. We call this as self-healing. Means when 10 goes down, 10 comes up automatically. Your automation should bring 10 servers automatically. Self-healing. When there's a problem in your system itself should be able to repair on its own. When 10 goes down, it has to bring 10 automatically up. Self-healing. If you want to automate this, achieve this with your own scripting or automation, very difficult for you to do it. That's where we think about Kubernetes tool. So what we do, we run these containers in something called Kubernetes, K8SPC in short, Kubernetes tool. So these containers are created by the Kubernetes and running in Kubernetes cluster, running in under supervision of Kubernetes. Think in that way. So you have 100 containers. You can tell Kubernetes once, right? hello Kubernetes, make sure that you have 100 containers always. That's a threshold you have set. If 10 goes down, Kubernetes, right, continuously monitors your, the environment, the actual state of the environment. If it finds that, it is violating your desired state. What is the desired state? I want to have 100. If it finds 90, that means actual state is not equal to the desired state. It will go on and bring 10 more up, and then make sure that 100 servers are there. Kubernetes can get that done very easily, quickly for that. Kubernetes has Google experience. Kubernetes was Google's internal tool. I told you, Google runs billions of containers for search, Gmail, and then file system and different applications. When they have billions of containers, so who will manage billions of containers? Is it possible practically for a human to monitor it? No. That's where they developed a tool called Borg. And then they open source that tool. Right? They wanted to give something back to the open source community. They've open sourced that, and that Borg is Kubernetes now. So Kubernetes has experience of running millions, billions of containers. Very powerful it is. Okay. So if it is Kubernetes, Kubernetes can make your environment self-healing, self-healable, self-healing. It can give you that feature. You have some code here. You always develop the new code, right? N+1 code. So we have to deploy this new code to existing environment. How do you deploy? When you deploy the new code, you should not bring your application down. We call that as zero downtime release. You should release the code without bringing it down. You would have seen in some applications saying, we're actually pushing some new updates for your benefits only. Please come back after 2-3 hours. Have you ever seen that in Gmail, Facebook? No. They push the new code every minute, every hour, every day, without bringing the environment down, without impacting real users' experiences. So if you have to automate it, very difficult for you to do it. If it's a Kubernetes, just tell Kubernetes, this is the new code. Make sure that new code is installed in all these machines. We call that as rolling updates. Rolling updates. How do you push the updates to the existing environment? If you have to manually do it, very difficult. How people usually do if there is no Kubernetes. You have 100 missions, right? They take out 50 missions from this load balancer. So only 50 missions are serving the users. They install the new code here. Then they switch the network, right? They switch the real users to this new code. These guys are experiencing new code. Again, they take the remaining 50 missions. They install new code here. They can switch to this. And this is this cluster 1, cluster 2. This has got new code. This has got new code. Once everything is working fine, then you combine, make it as 100. It's not so easy, that easy to automate it. A lot of challenges with this. Kubernetes has that intelligence for us. You don't need to do all that stuff. Rolling updates. Kubernetes can also help us with auto scaling. You can say Kubernetes, if the CPU, right, utilization reaches to the 90%, bring more and more missions. Correct? 90% is CPU utilization means what? Your application is, your infrastructure is overloaded. Missions are slow, so it can automatically go and add more and more missions. Again, when there is a less load, it will remove the missions. Why? Because you have to save the infrastructure, right? Correct? Auto scaling. Kubernetes can help us, with auto scaling. It has basically, a lot of features. Self-healing, rolling updates, auto scaling, rollback. Very important thing. You deploy the new code, right? The new code is not behaving to the mark as per your expectation. So what do? We have to remove the new code and then bring old code back without impacting real users again. Rollback. How do you roll back? If you have ever seen, rollback is kind of a frustrating thing and then very difficult to do it. You have to bring earlier system, say you have to bring the earlier state in your infrastructure. Very difficult to make sure the new code is removed and then you got the old state, basically. Very difficult. Kubernetes can help us with rollbacks, a lot of other features. So you say Docker and Kubernetes are complementary technologies. Means what? Docker says, right, hello Docker, yes, I'm very good, I'm able to create the container, but without you, I'm not much helpful to the users. Because Kubernetes is the one which is actually solving all these real-time deployment challenges, the operational challenges. Kubernetes say, without you, I'm meaningless. Without Docker, I cannot manage the containers. Because Kubernetes don't create the container. It is Docker which creates the container. It is Kubernetes which manages it. Complementary technologies. Kubernetes is very popular. Again, the Kubernetes certification has huge demand in the market now, right? If you know the Kubernetes and then if you have that, if you are a certified Kubernetes administrator, you are kind of hot cake, and then you are treated as a niche in the market. That's a niche skill. See the advantages of all these DevOps tools. By now you understand that the value addition of DevOps in any application, right? That is the reason DevOps is very popular now. There is huge demand in the market for DevOps engineers. Usually application support teams, production support teams, people who are working in production, people who are working in QA, like kind of a manual or automation, who thinks that their career is not progressing well, who thinks that they are drawing less salaries, who wants to change their domain, who thinks that they have the job threat, who thinks that if I upload my resume, I don't get the call, and then it's very difficult for me to switch to the new company, and I have to be forcefully stay in the same job, same company, no matter whether they give me a hike or not. That's a career threat, right? People who are in that state, right? Maybe mainframes are kind of dying technologies. People who are working in build and release. Earlier, DevOps used to be called as build and release, right? So few people only know these three tools. Their title is DevOps, but they work only on these three tools. A lot of companies do that. It's not that you get a chance to work on all these tools. Mostly these three tools plus maybe Docker and Kubernetes plus Terraform and things like that. It takes a lot of time for any project or company to adopt all these tools, right? To automate all these tools, because they have ongoing business headaches, and then they have some tight schedules. Basically, they have to push the new feature. They cannot spend their time in automating with these tools. So it is a step-by-step process. It takes more time for a company. So people who are working in these domains usually shift their career to DevOps because of the huge packages and stuff like that. It's a new area. I would say hardly 70, say hardly 20 to 25% of the companies have adopted DevOps. If you go to Flipkart and then ask them, for example, right? I'm just taking it as an example. Are you using these tools? Or are you still following the old methodology of configuration, old methodology of using the VMs? There is nothing, you're not using cloud. Are you? They may be in that state, or they would have moved partially to the DevOps tools. Hardly 20-25% of the company's projects have adopted DevOps so far. Remaining 75 to 80% of the companies are still waiting to adopt DevOps. That's where DevOps skills are very demand in the market now. The average salary in the US, if you see, like, right, $130, right, $130K. In India, it starts from say 8 lakhs to 8 lakhs, say whatever, somewhere around that. So if you are working in these areas, it's right time for you to move to the new technology, because say you are in application support. Companies these days know what they are doing. You say like you are operations guy, right? Once the code is deployed, then you come here, application production support, system administrators. Forget to mention system administration team, right? So all these people are operational teams. Now companies say, I'm not looking for only ops guy. I'm looking for someone who can automate this build and deployment process. I'm looking for somebody, a resource, who can automate build and deployment, and then as well as operations part. See here, DevOps engineers are kind of say interlinking connecting the dev, QA, and then operations part. So that's the demand you have now. So you may be very happy now, right? You may be getting the enough package with respect to your experience, yes. But after 10, 12 years, for example, right, you get 10, 12 years, your companies don't value you much. They say, yes, you have 12 years experience, but it doesn't matter for me, your experience. I can get the same thing done, right, whatever you're doing, with say 3, 4 years experience guy. So you lose the importance. When you lose the importance, what happens? You have to forcefully work there, even though they give you hike or whatever it is. Correct? We call that as career stagnant state. You don't have opportunities to become as a manager, to grow as a senior, to grow as an architect, technical architect, and things like that in few areas, right? That is a threat. So it's kind of, we call it as what? Career growth, right? You see the less career growth. I'm not blaming these things, but that's the trend you have. You have to move to the automation, right? Not in the old school, the traditional model. No. So it's good to upskill always, no matter whether you go into that, say DevOps or not. If you have these trends and things like that, hardly how much it costs you, right? 1.5 months, 2 months, right? If you spend 1.5, 2 months and then upskill the things, right? You see the advantage of this. So if you have these skills plus DevOps, right, or only Docker, Kubernetes also sometimes work, then it really helps you. Don't just we cannot just still live in that traditional operations and right models basically. That's about the DevOps. Okay, and we have something called DevSecOps. I think we are running late. Let me quickly explain what is this DevSecOps. It's a new trend here in Wiculty. We always follow the most trending topics. When there is a new topic in the domain, we adapt it and then we give it. We are experts. We are exclusive with respect to DevOps and then cloud related trainings, certification trainings. DevSecOps. See this? DevOps, right? With security blend. Why DevSecOps? Usually, right, in DevOps world, your development team, your QA teams, then your operations teams are working together. And who is that guy whose process it is, then whose tools, right, they are, which is connecting these teams? DevOps, right? They write the code, you build it and then deploy it, few people access it, daily testing. Once they test it and then again you push it to the prod, then comes the operating system, then comes your user. So it's all like DevOps automation, right? End-to-end automation. So Dev, QA, Ops teams are working very closely. In fact, these three teams go together for lunch. They know what other teams are doing. Dev know what QA is doing. Developer know what operations team is required. In fact, operations teams know, right, what are the requirements of this particular feature, what are the infrastructure requirements of this particular feature. So they are ready basically. So the moment developer writes the code, since they're all in sync, right, there is no without any confusion, right, they can test it and then they can move it. Earlier, before DevOps, right, we have the Avail, right? Avail. In Avail, we know what happens. In Avail, development and then QA teams work together, not operations team. So every day, same day, when the moment developer develops the code, same day QA also tests it. They know what is required, what other team are doing. In Avail, what happens? Okay, developer and then QA are working together, and then they have tested everything in QA environment. Then operations teams are sitting here. Operations teams are safeguarding this production environment. So they're kind of gods for this production. Their job is what? To make the environment run stable. So dev and then QA teams, right? They always try to push the new feature to the prod. These guys say, okay, stop. Why? It's not a right time because there are more users. It's a peak hours, or we are already experiencing some issue, and then we don't allow you to push the new code, right? Stop it. So developers always try to push the new code, whereas operations teams with that fear of missing stability, so they always don't allow very easily for these teams to push the code. Why? Because if something wrong, if something is wrong, they don't know, right, how to roll back. It may take more time and things like that. Assume that developer pushes the code. Operations guy says, right, okay, you are pushing the code, you are in the middle of the release basically, and something fails, and that fails because there is some issue. Operations teams are not ready with some infrastructure. They don't have a right version of the tool or something like that. Then development teams say, right, say we work very hard, and then you guys never understand what the code is required. Operations team say we never know what your code is required from the infrastructure side, so we are not ready. Why? Because these teams are working in a different silo. That's happens in Agile. If you handled or the participated in those kind of releases, this guy will shout saying, push my code. This guy will say, I don't push my code, you come tomorrow midnight 1 to 2, between 1 to 2 a.m. because right now, right, we have a lot of things. Because they always worry about the stability, they worry about the failures and stuff like that. In fact, these guys don't have all those Kubernetes, for example, to roll back and a lot of things, right? They are still in that, right, a traditional model. That's the problem in Agile. That's where DevOps term was coined. DevOps says this is the problem at the time of development itself, right? You bring these operations teams, right? You talk to these people and then let them know, right, what is required to run your code. So DevOps says development, QA, operation. When you write some code, it has to same day it has to build and then deploy to the QA, and then you have to involve the operations teams to automate the processes which are required to run that particular code. So same thing, right? Like we have the Kubernetes and everything basically. So DevOps brings development, QA, and operations teams together. Everybody know what, right, others are doing, and then there is no last minute surprise basically. Understand that? So DevOps is a development methodology. You understand more about these things later, like when we actually get the stuff. DevOps is a culture. DevOps is a methodology. People call it as a philosophy. It's a culture. It's up to you whether you adopt that culture or not. Right? If Flipkart has all these tools, the benefit. If this guy don't say, I don't want to take these tools, I don't want to adopt this culture, it's up to you. Right? It's a culture. Right? If you have the DevOps culture in your application project, then you see all these advantages. It's a development methodology. If your application has this DevOps culture, if you are developing your application with these tools, then you develop your application within less time, and then less money, and then you push the code to the customer very fast. It's a philosophy, right? Kind of. So that is DevOps, right? Which brings development, QA, operations, teams, processes on a single page. And mostly now there is something called security, right? Security teams are still working in a different silo now. So usually what we do, we develop the code, we build it, we deploy the code to the QA, we do the security testing here. Or in some companies, some projects, after deploying the code to the prod, then we just at a very high level we do the security things. We don't concentrate much on the security. Assume that you're right, you are taking care of some, you're doing the security check here. What happens now? There is some issue. You report it to the developer. Developer says, I have already developed the application. Few people have already tested it. It is already in the production. And now you say that there is some issue. If you ask me to solve this issue, I have to rewrite my complete code. I have to change the complete architecture of the application. I need 10-15 days to again fix that. I have to change a lot of things. See the surprise now. Why this is happening? Because you are testing this at the end. What if you can test the security things here itself better than this? What if you can test the security at the time of build? What if developer takes care of the security testing at the time of development itself in his local environment? See the advantage now? Left shift. Usually dev, QA, dev build, QA, and then production, right? You can test here. It is better if you can test here itself. Here itself. If you are moving left, right? So left, we call it the left shift approach. Means it is good if you can test at the early stages itself. So that is the gap I was talking about. That gap was there with operations teams also. Now it is with security teams. Security, you're not taking care of the security things here. You're not taking care of the operational part, right? In Azure, you are not taking care of it. Developers don't use Docker. Developers don't use, all those operational automation things here. So since it is not that, like, you see a lot of surprises, correct? So in some applications, like the finance, banking kind of applications, security is a real important for us. That's where there was another terminology called DevSecOps. It says along with DevOps, right? In DevOps end-to-end ecosystem, right? In that DevOps lifecycle, you also integrate the security-related automations. So security DevSecOps suggests us to have the security-related automations at the early stage itself. What are those things which you can take care of at different levels? Whenever developer writes the code, right? What if developer checks, the quality of that particular code, whether it is understandable, right? Whether the code has any usernames and passwords embedded already, whether that code is, right, giving attacker a chance to log in as a root, whether that developer is unnecessarily opening a network port so that attacker can attack your application. What if you can check here itself? There are some tools, PMD, check style, and things like that. So when developers write the code, if they have those tools installed and then they verify, most of the problems are rectified at the early stages itself. If you rectify here, what happens? You can do that, but development is already done, and then you're rectifying here. Now you report this guy may have to change the code. It's code, right? If you have rectified it, if you rectify here itself, this guy can fix very early. Here it is already delayed. This guy has to again change it. See, the things now. Here, if you want to, if you want to fix it here, it may take say 1 hour for you. And here, if it is identified here, it may take 1 day. Why? Because assuming that this works, this guy had built a lot of other code on top of this, and now you say like this guy has to change everything. So you call it as fail fast, fail early. If you can fail the things here itself, it is good early, and you have to try to fail fast. Developer commits the code morning, and then evening you tell that there is a issue. Whole day assuming that code is morning code is working fine, this can develop a lot of other things, and now you come in the evening saying this base code is wrong, so he has to rewrite everything. Fail early, fail fast, right? So there are some tools basically here using which you can go and then check all these security vulnerabilities at the time of development itself. Yes, then you are done. You are able to rectify a lot of things. I'll not take more than 3-5 minutes. Thanks for staying. It's we're running a little late, I know that. You are rectifying a lot of things here itself, right? 3 to say 5 minutes. Okay, sorry, you're rectifying a lot of issues here itself, okay, at the time of development itself. Okay, your code is right, code passed through some quality basically already. Then you have the code here, then you take the build. Once you compile that, before you build this, before you deploy that particular war file in this QA production environment, you do the security check, few more security checks here. For example, sometimes developers you may copy the code from the Google. Is there any guarantee? Do you check that that code which you are copying from the Google, right, when it's not from the Google company, right, from the search from internet that you copy is a open source? Do you know that? It may be some company's proprietary code, right? If you take the code and then push it as part of your project, If that company knows that you're using their logic, they will sue you. So how do you make sure that the code that is being pushed to your production is meeting all those licensing rules basically, correct? So you have to scan your code to see if you are using any code which is it's a proprietary, which has the proprietary license basically, which is actually the open source which you are using. You have to confirm that, right? You can scan that basically. Does that mean that we have to play the security role also? No, we are jack of all trades. We are not developers, we are not QA, we are not pure operations, we are not security. We are DevOps who understands the process of dev, QA, ops, security, and bring everybody on the same page. We are jack of all trades, but we are masters in our own area, right? Our own tools. We don't need to know any security things. There is a separate security team. We go in and say, hello, I want to integrate your security things here itself. See, it is DevOps engineer who gets a chance to push that code to the production without our notice, without DevOps engineer's approval. Code will not go to the real user, correct? You take the code, right? You take the code. The developers cannot directly push the code to the prod. No, they won't be doing that. So you take the code, you can do anything here. You can do licensing check, you can do testing, or you can do anything. If something is good, you deploy it to the prod. If something is not good, you throw it back on developer's face, right? Saying this code is not meeting the quality criteria, right? And you have to come back. You have to fix this and then come back. Then I will again verify it. And if it is good, then if it is meeting all the quality criteria, then I will push it. It is DevOps engineer who gets a chance to fail the code, to scan all these things. So what do? It's a practice, right? So we go to security guy and say, team, if you want to check anything, let me know, right? Just give me the command. You know what we do? We just run one command. There is a tool called say Black Duck. You give this code to the Black Duck tool. Black Duck scans your code and then will tell you if there are any licensing violations, for example. We don't need to know the Black Duck. We don't need to know anything. They give the command. We just run it after the Maven and we generate the reports and then we give it to them. We publish the reports on Jenkins. Jenkins has a feature to publish the reports. We publish the reports. And if they say that, okay, if this is the case, don't deploy. We write the check in our automation. If 90% pass, then move it to the prod, otherwise fail it. Here, we are not security experts, but we are injecting their processes in end-to-end life cycle basically. So your code is going through the security check at the time of development, at the time of build. Then obviously after the deployment, you can trigger, they have some automation test cases. You trigger their test cases and then generate, throw the reports back to them. Correct? So that's what the security says. At the time of development itself and then early stages, if you can, ask us also to, if you take us also for the lunch and then dinner, let's discuss we can discuss, we get a chance to discuss. I can tell you what we require so that you can take care of all these things at early stages itself and then everybody is happy. So your code moves to the end user safely by passing through all these teams, say all these teams rules and gates basically, correct? DevSecOps insist you to bring the security related check, right, as early as possible in your end-to-end SDLC process. Okay, so at the time of development and then testing and things like that. That's about DevSecOps. As part of DevOps, I also spend almost 3 to 4 hours to discuss about various tools that we have in DevSecOps and best practices, how you say configure these tools, in which stage you integrate a particular tool and stuff like that. For example, there's something called pen testing, okay? Penetration testing. Usually after deployment, we run that penetration testing. So this is where we check all our networking ports and root access and a lot of things. There are some rules basically, right? So we call it WASP 10 rules basically. So whether your code is following all that stuff and things like that, right? OWASP we say. That's about DevSecOps. Okay, I'll take your questions. Okay, before I take your questions, just one quick thing. I just want to iterate the unique things that you get in the Wiculty. As I mentioned, right here in Wiculty, you take any the tools, any courses. We have well experienced trainers. For example, I handle DevOps primarily here. I have almost 14 plus years of experience, right? My last company was Walmart Labs. I got a huge opportunity to learn a lot of DevOps things. That time, like DevOps was completely new when I joined Walmart. I got a chance to develop the things from scratch. I carry that core technical experience. So the all trainers are well experienced, right? In Wiculty, it's a, as I said, it's a exclusive, exclusive for DevOps and then cloud. So we are kind of laser focused. It is very extensive. If you see, a lot of people teach DevOps 35 hours, 40 hours. Here, we spent almost 60 hours. 60 years only, the theory and then practical, and theory and then practicals and stuff like that. As I said, there is no theory here. Right? Less theory. We don't believe in slides or slides. It's mostly the real time. As I mentioned, we have the projects, and then you take the projects, you practice all the things. For example, whatever I have mentioned here, everything will be practically doing it. It's not just a theory based. If you spend 30, 35 hours, like what do you learn? Right? These many tools, it's very difficult for you to learn. So it's a practical based, extensive training. Apart from this, I didn't tell you one thing. So with this DevOps, if you take, right, we also give you a Linux plus shell scripting, a self-paced free. It is almost 25 to 30 hours. So shell scripting recorded sessions will give you apart from this DevOps. So 60 plus 30 hours, and we also give you the projects, which will which needs almost 20-30 hours of your time, kind of things. So these are the unique things that you have in Wiculty. And here, like if you miss any class, right, we give you those recordings also to you, so you can refer the recordings, and then you can also say get in. You can also continue in track basically. So you get class recordings and things like that. Okay, and then it's almost kind of a trending topic. If you ask me, I would have trained more than say 6,000 to 8,000 students so far, DevOps. More than 600, 700 batches I would have handled, right? Excluding the corporate trainings, kind of things. It's like we give that classroom kind of teaching experience online. That's about the Wiculty things. And if you are interested to take any cloud courses, you also have we also help you a lot with the certificate for your certification preparations and things like that. The other thing, we also give you the job assistance. Like once you finish the course, we help you to prepare the resume, right? And then when you're giving the interviews, for example, you can call me always, and then I'll help you with the questions and stuff like that and things like that. So a lot of job assistance things also. That's about me, Wiculty, and then the USPs that we believe in and then follow. That's all I have. Before I take your questions, I just wanted to say that thank you for your time, and then thanks for staying little late. I have received a lot of questions basically in the chat room. When I get some free time, maybe I'm really jam-packed weekends usually. Maybe Monday I'll definitely answer to all your questions that you have posted in the chat box. Okay, so lot of questions. Okay, thank you very much. I'll definitely respond to you. Let me take the questions if you have any now. Few questions that are in the chat box, I'll definitely answer to you later. Or if you want to ask now, you can go ahead. You're all unmuted now. You can please go ahead. Any questions? Go ahead. Feel free to ask any question. Anything it is. Any confusions? You can note down my number also. Okay. Let me give you my email ID so that you can also send me the questions offline. If you need any career guidance. For example, I'm working in this domain, I want to change to DevOps, I have confusion, I'm in a confusion to choose this course, that course, a lot of things. You can ask me anything.
I have a question. Hello?
One second, please. Nageswara.rao at wiculty.com. wiculty.com. All in small. Go ahead.
Hey, I have a question. When you co-host different vendors on the cloud platform, is there a way that the data breach can occur? Because the people can steal the customer information and sell it to somebody for marketing purposes?
I didn't get the question. Is it like, say you are asking, you have some information in the database and you want to protect your data that you have in the database so that others don't steal the database.
Yeah, in the data center, mostly in the data center, you co-host different vendors, applications, and all those things, the data and all.
Mm-hmm.
So in those cases, is there a breach can happen, or how it is going to be prevented? It's based only on the data center security policies or agreement between the vendors.
Mm-hmm. Mm-hmm. So basically, you have. I'm not a cloud expert, right, or database expert to answer that question. Certainly, like if you have any, say, if your infrastructure is in, say, AWS or Azure or cloud and things like that, if you have the machines here, they definitely have a lot of services which will help you, to protect the data. Which will you can decide basically, you can when come up with all those firewall settings, who can interact with your machines, who cannot interact. Sometimes the people think that okay, I have some data and then I don't want to keep my data in AWS or any other cloud. I don't want to believe them. I don't want to bear even 0.001% of damage. That's the perception you have. So they give the security in a way that even AWS, right, so they cloud providers own employees also cannot see the data. They encrypt the data, right, to that level, so it's all safe. On top of that, if you want to say stop these attackers, and the things like that, there are a lot of services. Basically using those services, you can stop attackers or the outside users to enter into your system unofficially and then do something. There are some services. Basically you can basically do that at a cloud level using different cloud services, and the database level also. I'm sorry, I'm not expert in either cloud or say database, so I cannot give you the exact tool, right, or the services, but there are a lot of such solutions. There are a lot of such solutions.
Okay, thank you.
No problem. Any other questions?
Hi, I have one question.
Yep.
How technical a person needs to have a background with to get on board with DevOps?
Okay, that's a good question. So I'll tell you one thing: DevOps don't demand much of the analytical or programming skills. Yes, scripting is kind of very much required for you, but it's not required. It's not that you'll be writing the scripts every day. Any one basic scripting, if it is kind of added advantage. So all these tools are command line oriented tools, not say a programming oriented. Basically, for example, in Maven you have to define the configurations in something called pom.xml file, right? And in Kubernetes you have to you should know how to write this YAML file basically. And these are not programming languages, these are not scripting languages, it's a configuration basically. We call in DevOps world, we call this as declarative syntax. Declarative syntax means what? Configuration. Like you tell what you want at a very high level, what you want at a very high level, the tool gets the job done for us without you worrying about the how part. So if it is a programming, what is the problem? To solve the problem, you have to write thousands of lines of code basically, right? You read thousands of lines of code. That's the how part. You have to develop how you have to write a lot of code to achieve to get the task done basically. How part. So that's the real development. What is the problem? How you achieve it? You have to write the code for that. But in DevOps, all these tools are command line oriented tools, and even you are writing some configurations and lightweight scripting, this is the declarative. At a very high level, you just say, tell Kubernetes, I want 100 missions, create 100 containers from this image, make sure that port number 8080 is open. Just you tell at a very high level with a simple syntax, and it will get the job done. So I candidate no need to have much analytical skills, much programming, but right, you can start with learning these tools, command oriented tools. Lot of processes, lot of the coordination is required between the teams, as we discussed. So most of your job will be coordinating with the team, most of your time you spend in coordinating the team with the team members, and then you know kind of so running these processes and then troubleshooting and kind of things. So it's really challenging, yes, because you see that tools list is too long, but these are all the small tools basically. If you enjoy talking to multiple teams, if you enjoy helping companies or projects, say introducing the best practices and working with different teams end to end, starting from the development to the maintenance and then the releases, this is the perfect job for you. DevOps in this are much valued in any project or company.
Sure, thank you.
So far, see, if you think that you are say weak in programming, that's still okay. You can start with this. See, nobody can learn the things overnight. You can start with this. Once you get into DevOps, then you can concentrate on learning one scripting language. It's not a big deal. It's not very difficult like a C, C++, Java kind of programming languages. And it's not mandatory that you need to you have say a script. You need a scripting. If you get say 10 interview calls, maybe 3-4 calls may demand scripting for sure, but there are still 5 to 6 calls who don't expect much scripting from your side. Okay. Any other questions?
Hey, I have one quick question. So, you talked about the CI/CD, the CI/CD process where you continuously integrate and continuously deploy.
Right.
So my question, the circumstance what I have in my workplace is that like, I mean, how do you just configure with this Jenkins in terms of agents? So say for example, like I have a pipeline in process, and in my pipeline, like I have to, I have been given a designated agent in my pipeline. So what happens is that like, but we have like various kind of automation needs. Say for example, under one environment, we need to kickstart an specific set of uh, features, and in another. So what we have basically done is that we have done using Groovy. Okay, we have a Groovy. We just did a Groovy programming at the Jenkins just to enable some different kinds of test runners kind of thing. So my question to you is, would I mean like if we enroll in this program in the upcoming days, like would you also help us master in Jenkins how to create a slaves and basically how to manipulate the slaves based on our requirements?
Yes, definitely. Yeah. We have all those concepts covered as part of the Jenkins, as you mentioned, right? So in Jenkins, you can create the pipeline in a GUI way, correct? As you said, GUI way. So that means you fill different, the configurations, and then you configure your clone, build, deployment, and the notification part. But usually we prefer to automate the process using the pipelines. That is, the scripted way of creating a job. It is. We call it as a pipeline, correct? Pipeline. In pipeline, what we do, as I said, we write the Groovy code, correct? Groovy code. If it's a Groovy, it's very flexible. It's a portable, basically. So if it is GUI, you are limited to use only the GUI options that you see in our Jenkins dashboard. If it is a Groovy, it is a script. It is up to you what you write. So you have a great flexibility in automating, the complex automations, basically. Okay. So we have a pipeline. Pipeline basically like why we create, right? We separate the tasks, right? We split the task into the smaller pieces. For example, we have only the clone here. Then say for example, you create another job or another, say you call it a stage, right, in a pipeline. which will do only the build, then which will run only the test cases, then which will only deploy the code, another stage, then you send the notification. So you have these many tasks. If you configure everything in one place, what happens? Assume that all these things are passed and the deployment fails. You cannot rerun it. Once you fix the problem, if you want to execute it, you have to again start everything from scratch. When you have already, when you already have all these stages success, why you are again starting from start? That's where we go to the pipeline, right? Okay, so in pipeline, we split the task into different pieces, and then we try to execute as a smaller chunks. So even if this fails, for example, since it is a separate task, separate job, you can still run this from where it failed before. That's the pipeline concept. Okay. Second thing, pipeline also brings you the flexibility wherein you can run different stages parallelly in different missions. For example, if you can do the test case execution and deployment in parallel, you can run this in one mission, this in second mission, instead of going in sequence. So if since you are able to run the things in parallel, you can reduce the build time, deployment time, and a lot of things basically here. Now the question comes, how do you run these two things in parallel? Correct? So we go to the master slave concept. So in master slave, yes, we cover that. We'll be setting up the master. We'll be adding, agents. You got the agent, a slave node, or whatever it is. Then we have say 100 jobs. How do you distribute 100 jobs to be executed on this distributed environment? Distributed builds, you say, right? You can run 20 here, maybe 100 here. If you want to run 1,000 jobs, right? 200 here, 300 here, and things like that. Yes, will be practically, taking multiple missions, will be attaching these agents to the master, will be kicking off the builds on these slave nodes, and then we'll be deploying it. Yes, this is there, and then we'll be discussing this pipeline concept also very thoroughly. Yes, I covered that.
Yeah, thank you so much. That helps.
So yeah, you mentioned that you want to deploy the code in different environments, right? You can also do that. So for example, in Jenkins, we'll be learning one concept which is called the parameterized build. You can use a single job, to deploy the code to the QA, SIT, prod, and things like that. So you'll be passing kind of the parameter. If it's a QA, it will deploy the code to the QA, same job, then to the prod, then to SIT, and things like that. We'll be configuring all those things practically, taking different, branch code and then deploying it to different environments. Yes. Okay. Any other questions?
And just one more quick question. So regarding this course fees and everything, like will that be in separate one-to-one email, or would you discuss that in this call?
The course advisory team will contact you. We have your contact numbers. You can also directly go to the wiculty.com and then you can check different things here. So if you see, like, we have only like DevOps and then cloud courses. This is the price that is running now, right? It keeps changing, right, based on different things. I think this is month end of something. Okay, 35. I think till yesterday there was 30%. It is 35%. You can go there and directly enroll here, or you can contact these numbers, right, for any other queries. I think my team also will reach you for sure. Any other questions? Okay, you can note down my email ID. If you have any other questions or anything you want to talk to me about your career or any other things, feel free to send me the email. I will definitely get back to you.
Yeah, sorry, I have one more question. So right now, I'm in a DevOps platform, and right now, basically, I'm an automation engineer. So what I'm trying to do is that, like, I'm in charge of like both the non-pipeline and the pipeline architectures. So when I was doing earlier, like the non-pipeline was never a big problem because it was mostly consuming the GUI based features, and the pipeline is where we started to doing some automating the pipelines. Like as you mentioned, there are different stages of environments, build process, and the code quality where we check, and different options of running different kind of scripts. So, but I see the entire industry is now shifting from DevOps to cloud systems, and but I'm still not familiar with all the DevOps. Like one thing is Kubernetes, and I know the Docker, the containerization is effective, and the Docker model. I still don't have access to this Docker systems, and how do you kind of write the Kubernetes? You said Docker and Kubernetes go in hand. So I just want to be familiarized with this, but I know DevOps is becoming a little outdated going forward with what I see. The question to you is Kubernetes, Dockers will all be, can we see those technologies back in cloud as well, or that will go extinct with all the cloud updations what we have?
Okay, so one small correction from my perspective. When you say DevOps go out of date, it's not it's not how you categorize. It's not that Docker Kubernetes is say advanced to the DevOps. All these tools together comes under DevOps. It's all DevOps only, correct? DevOps means all these tools, so different
Correct. Yeah, no.
problems
Yeah.
that you're solving. So yeah, Docker Kubernetes is also part of DevOps only. So it's not that Docker Kubernetes is
True, I
advanced and then
understand.
DevOps.
So yeah, maybe there are two different projects in the enterprise where I work. So one project is in the DevOps, and the other one has migrated to cloud. So before I go to cloud, so if say for example, if I'm seeking an opportunity in cloud kind of an technology, so say be it AWS or be it Microsoft Azure. So my only thing, so I have close to 12 years of experience, and I cannot just go and begin I cannot come from the scratch, or I cannot start my career from the beginning, even though I have a couple of years of experience in DevOps. So I have to, what I do is that I have to do my own homework before I go, do a lot of assignments, and aspirant enough to go to the cloud. I have to be little competent enough to go take those things in cloud. So my question was will these Kubernetes, Dockers will all be, will they be using the similar technologies in cloud, or cloud is completely different?
Correct. That's a question. So there are different ways to do it, right? For example, when I say we talked about the Kubernetes, right? We talked about the Kubernetes here. So in Kubernetes, if you see Kubernetes, we have again the master slave concept. So this is your Kubernetes master. This is your, say, worker nodes, okay, the slave nodes. For example, for your Flipkart application, this is a cluster basically. This is you, right? You write the YAML file. You say, I want 100 containers, right? From this particular image, and from this particular, and then I want this port running. You give your demand to the Kubernetes, KETS master. Kubernetes reads your information, and then it goes to this particular cluster and then creates 100 containers for you. 100 containers. That's how it was at a very high level. If you said cloud, non-cloud project, right? If it is non-cloud, this is what we do. What we do, we go and then set up Kubernetes in our own mission. 1, 2, 3, 4. So we take 4 missions, we install Kubernetes, and then we attach 4 missions together, and then we run our application on our own infrastructure, on our own, say, cluster basically, right? The Kubernetes cluster. This is one way of doing it. The second way, the cloud way, right? Which is, yes, that is very much important, especially when you say that you have 12 years of experience. In second approach, in cloud approach, what we do? Cloud is what? Everything is a service, right? You don't have to actually, say, set up your own master and then, the cluster, take the worker nodes attached to it. No, you don't need to maintain it at all. In cloud, there is something called EKS, right? Say, Kubernetes service. So what you can do, you just give this YAML file to your cloud, your demand. You don't need to worry about these low-level things. It is your cloud provider who prepares the cluster, and then who gets the job done. That's all. You don't need to even worry about this. We call this the service. Service is what? You don't have something, they do it on behalf of you. You just consume their service and then you get your job done. So there is a Kubernetes service. One guy set up everything on his own. The second person goes to the cloud and then just says, this is what I want. And then you have you set up the Kubernetes for me, and then I'll consume that as a service and I'll get my job done. If you do it, what happens? What if you need to have 1,000, you need to get 1,000 containers, for example. You have to go and attach more and more missions. What if automatically you have to scale up? Say you want to get 2,000 containers. So first you have to go and then add a mission to the cluster manually, then do it. If it's a cloud, no matter how many missions, how many containers you want, you don't need to worry about adding more and more missions in the backend. They do it. Let's scale auto scaling automatically. That's where people prefer to use the service, but there is a cost involved for it, right? Sometimes for example, Facebook, they don't worry about the financial things. What they worry about the best, the user experience. So in that case, they don't mind in shelling out the money in purchasing this service. So there are different services in the cloud for everything. You can set up your own Git. For example, you maybe since you pointed out, I'm sure you know this, right? AWS DevOps, Azure DevOps. In AWS, you know what you can do. You don't need to set up your own Git. You don't need to set up your own Jenkins, and you don't need to set up your own Kubernetes. Just create a pipeline basically, right? Just point where your code is, and then you don't need to set up anything, any of these tools. They will help you, they will make your code go to the production seamlessly. And all these are services. They have their own Jenkins, they have their own Kubernetes, they have their own Docker. You don't need to, in fact, create the, say the image. You just give your code, everything goes, right? The pipeline basically, and everything goes through on top of their setup, and we call those things as a service. They have different services. So DevOps is core. Azure DevOps is a creamy. Means what? See, in Azure DevOps, if you have to set up, if you have to work with Kubernetes, you don't get a chance to set up this. No, you just write this and then give it to Azure, right? They will get the things for you. You don't know how Kubernetes is working, what is Docker, how exactly things are happening under the hood. That's Azure DevOps. Everything more automatic way. What I suggest, a person should first learn DevOps, right? And then you go with those services. Not all companies use those services, and Kubernetes and these kind of services are premium, that you have to pay for that. So it is just kind of another level of the easy automations that cloud gives you. So it is good to learn, yes, for sure. If we work in a large enterprise kind of applications, and those applications don't set up their own Kubernetes, that time we should know how to use their service, consume their service. So this is what I feel is better. First we learn the core Kubernetes, we know Kubernetes, and then it is like anybody can do it. Any dumb guy can just write this YAML and then consume that service. It's just a GUI configuration, but the real challenge comes whether you know how Kubernetes works, whether you know the core concept first. So first you learn DevOps, then you go and then learn those Azure AWS services which are related to DevOps. Does that help?
Yes, sir. Thank you so much. Yeah, that really helps.
No problem. Any other questions? Okay, that's all. Thank you very much. Have a good night, good day, depending on where you have joined us. Bye-bye.